In this video, we're going to transform a Riemann sum to an integral. Express the following limit as a definite integral. Limit n goes to infinity, summation j goes from 1 to n, j over n squared, cosine of j squared over n squared. Let's start with the definition of the right-hand Riemann sum. Limit n goes to infinity, j goes from 1 to n, f of xj times b minus a over n, that's equal to the definite integral a to b f of x dx. This here is delta x, b minus a over n, that's your delta x. Alright, the key to solving this question is pattern recognition. So let's find xj, a, which is the lower limit of the integral, b, the upper limit, the function f of xj, and delta x. Okay, let's rewrite this in a way that shows xj and the delta x. Limit n goes to infinity, j goes from 1 to n, j over n, cosine of j over n all squared, times delta x, which is 1 over n. So this is delta x, 1 over n, that's delta x. And this should be equal to the limit n goes to infinity, j goes from 1 to n, f of xj times delta x. Alright, so we can clearly see that this part of the Riemann sum is f of xj. So this is going to give us the f of xj, and that's basically analogous to this part of the Riemann sum. Delta x is 1 over n. Alright, let's start with xj. So xj, that's going to be j over n. Let's plug in different values of j to find the x values. So what we have is x1, plugging j equals 1, that's 1 over n. x2, that's 2 over n. x3 is 3 over n. And xn is n over n is equal to 1, that's equal to b. That's the upper limit. Now, we know that delta x is b minus a over n. That means that, and that's equal to 1 over n. So what that means is that if we compare the numerators, b minus a, and compare that to the numerator 1, we get b minus a is equal to 1. But we already know that b is equal to 1. That implies that a is equal to 0. So now we know that xj is j over n. The function builds itself around xj. So f of xj is going to be j over n cosine of j over n all squared. That means that f of x is equal to xj cosine of xj squared. So that's f of xj. So that also means that the function f of x is equal to x cos of x squared. We have a is 0, the lower limit of the definite integral, b equals 1, the upper limit of the definite integral. We also have the function f of x is equal to x cos of x squared. Alright, so now we can clearly see that we can transform the Riemann sum to a definite integral. So we can rewrite limit n goes to infinity, j goes from 1 to n, j over n, cosine of j over n all squared times 1 over n. That's equal to integral from 0 to 1 x cos of x squared dx. Now it's clear that this part is f of xj. So that's f of xj, that's the functional part. That's f of xj. And this corresponds to this part of a definite integral, which is f of x. And for the Riemann sum, this is delta x, and that corresponds to dx in a definite integral. All right, thanks.